Prior Analytics, Chapters 1 through 3. Aristotle's Study of Reasoning, explained. Before discussing the specific content of the book The Prior Analytics, it's important to contextualize this book within Aristotle's overall corpus. According to St. Thomas Aquinas, the great interpreter of Aristotle, there are three operations of the intellect. The first operation is called simple apprehension, or the understanding of indivisibles. The second operation is knowledge by composition and division. This is also called judgment. This operation composes or divides simple objects from the first operation of the intellect. The third operation is called knowledge by reasoning. In this operation, we reason from something known in one of the other operations of the intellect to something unknown. The first operation corresponds to words, names, or terms. The second operation corresponds to sentences, or propositions, and most especially the special kind of sentence, the enunciation. The third operation of the intellect corresponds to syllogisms, or arguments. Now, each of these three operations corresponds to certain works in Aristotle's logical corpus, which is called the Organon. The first operation of the intellect is studied in the book The Categories. The second operation of the intellect is studied in the book On Interpretation. And the third operation of the intellect is studied in the books The Analytics. Now, the Analytics are divided into two parts: the Prior Analytics, which studies syllogisms in general, and the Posterior Analytics, which studies the demonstrative syllogism. This is a special kind of syllogism, which we'll discuss a little bit later on. The verbal expression of reasoning is the syllogism, or argument. Aristotle defines a syllogism as follows. Quote, "A form of words in which, when certain assumptions are made, something other than what has been assumed necessarily follows from the fact that the assumptions are such." In other words, a syllogism is a form of words, that is, an ordering of verbal expressions, in which a certain conclusion is drawn necessarily from certain assumptions, which are also called premises. Notice that the conclusion must be something other than what the premises themselves or the assumptions themselves explicitly state. The conclusion is something else that is drawn out of those assumptions or premises necessarily. The assumption may be viewed as corresponding to this picture of a building. The parts of a syllogism are the premises and the conclusion. Thus, the premises and the conclusion correspond to the parts of a building. A premise is an affirmative or negative statement, that is, an affirmative or negative enunciation, of something about some subject. In this definition, the word something designates the predicate of the premise, and the word some subject designates the subject of the premise. In other words, a premise is an affirmative or negative enunciation of some predicate about some subject. A premise corresponds to the foundation of a building. A conclusion is defined as what necessarily follows in a syllogism. A conclusion corresponds to the roof of a building. Just as the roof of a building depends on the pillars and foundation of the building, so too, in a syllogism, the conclusion depends upon the premises. The conclusion, as we saw before, is something that necessarily follows from the premises in virtue of the form of the syllogism. There are multiple ways of distinguishing the different kinds of premises. The first way is to consider a premise not as a premise, but in itself as a statement or enunciation. This should look familiar to anyone who's read the book by Aristotle On Interpretation. A premise is divided into universal premise and particular premise. A universal premise is a statement which applies to all or to none of the subject. For instance, in the premise, "Every dog is a mammal," mammal applies to all of the subject dog. Likewise, in the premise, no swan is black, black applies to none of the subject swan. A particular premise is a statement or enunciation which applies to some of the subject, or does not apply to some, or does not apply to all. Here are 3 examples corresponding to these 3 options. Some dog is a mammal. Some dog is not a Labrador. Some dog is a Labrador. Notice in the first case, mammal applies to all dog, and therefore it applies to some dog. Because since some dogs are part of the totality of all dogs, it follows that because mammal applies to all dog, it also applies to some dog. In the second example, Labrador applies to some dog, but it doesn't apply to all. That's also the case with the third example. Labrador applies to some dog, but not to all. Aristotle also brings up the option of an indefinite premise. These are premises ambiguous with respect to quantity. We will ignore indefinite premises. Notice that Aristotle has also ignored singular premises. And on interpretation, he divided statements or enunciations into universal, particular, indefinite, and singular. In this book, he only brings up universal, particular, and indefinite premises. He ignores singular premises. Later on, he will have very little to say about indefinite premises, so we will ignore these and focus only on universal and particular premises. The second way to divide a premise is to consider it as a premise of a syllogism. Here we could divide a premise into a dialectical premise, a logical premise, and a demonstrative premise. A dialectical premise is an answer to a question about which of 2 contradictories is to be accepted. In other words, what happens when we assert a dialectical premise is this. Suppose we don't have a strong position on which of 2 contradictories should be put forth, or we're willing to let the person with whom we're speaking, that is, the interlocutor, decide which of 2 contradictories to put forth in an argument. We might give them the option to decide which of the 2 contradictories should be put forward. So we pose them the question, do you want P to be predicated of S, or do you want not P to be predicated of S? We give this question to our interlocutor, that is, the person we're speaking to. The interlocutor answers the question by determining that they want P to be predicated of S, or that they want not P to be predicated of S. We accept whatever their answer is, and that becomes a dialectical premise in our future argument. In a logical argument, we take an assumption which appears to be true and is generally accepted. In this case, we don't ask our interlocutor to come up with the premise for us. Instead, we take our premise from what is, so to speak, common knowledge or common sense, something which most people agree to. For instance, we might say murder is wrong is a logical premise because it's something that nearly everyone will concede in an argument. Despite the fact that nearly everyone agrees to logical premises, they aren't always self-evident in themselves. Often they're technically things which need to be proved from more self-evident or more fundamental premises. In contrast, a demonstrative premise is this, an assumption that is from one of 2 contradictories and that is true and based on fundamental postulates, that is, self-evident statements or enunciations. In other words, a demonstrative premise is something that is necessarily true because it's self-evident or based on self-evident premises. This differs from a logical premise because a logical premise might actually be false, though it might be true also, and because a logical premise is not proven by means of self-evident statements, but instead is taken for granted as something that everyone agrees to. Aristotle also divides premises and propositions or enunciations more generally by modal qualifiers. What modal qualifiers are will become more clear by the three examples of them. The first sort of proposition that results by the division through modal qualifiers is the assertoric proposition. This is a proposition in which the attribute, that is the predicate, applies to the subject. No qualification added. For instance, every swan is white. White applies to the subject swan, no qualification being added. The second kind of proposition that results is the apodeictic proposition, which is also called the necessary proposition. In this one, the attribute applies necessarily to the subject. For instance, it is necessary that every swan is white. Notice that the content of this proposition is the same as the content of the assertoric proposition. They differ, however, in that the modal qualifier, it is necessary that, is added. The third kind of proposition that results from this division is the problematic proposition. This is also called the possible proposition. In this one, the attribute, or predicate, applies to the subject possibly. Such propositions are ambiguous, because the phrase, "it is possible that," can mean one of three things. These three meanings are laid out partly in Chapter 3, and partly in Chapter 13. The first possible meaning for the phrase, "it is possible that," is this. It states that what may or may not be necessary, but which at least is not impossible. Here's an example. It is possible that every swan is white. Notice that this meaning of possible, or it is possible that, is consistent with propositions which also are necessary or assertoric. The second meaning of the phrase, "it is possible that," is what is probable or natural. That is, what generally happens, but what falls short of being necessary. Here's an example. It is possible that every man get gray hair. Now, there might be some man who gets old without getting gray hair, but it's natural or probable that if a man gets old, he will get gray hair. The final kind of problematic proposition is this, one which is indifferent, or a matter of chance. This is the indeterminate, which is capable of happening both in a given way and otherwise. For instance, it is possible that there will be an earthquake. In such a proposition, the subject has no natural inclination to the predicate or away from it. The parts of the premises and of the conclusion are terms. Aristotle defines a term as follows. Quote, "By a term, I mean that into which the premise can be analyzed, viz., the predicate and the subject, with the addition or removal of the verb to be or not to be." End quote. Here's an example. Every swan is white. First, let's cross out the quantifier every and the verb to be, that is, the verb is. What results is merely the word swan and the word white. Swan is the subject, white is the predicate. So the two terms in the premise, every swan is white, are swan and white. Here's another example, this time with a modal qualifier. It is necessary that every swan is white. Again, let's cross out the quantifier every and the verb to be. Let's also cross out the modal qualifier, it is necessary that. The result is that we merely have the word swan and white. Swan is the subject, white is the predicate. These are the two terms in the premise, it is necessary that every swan is white. The conversion of propositions is one of the most important concepts in logic. When we convert a proposition, this means we reverse its subject and predicate. So for instance, from the proposition, some swan is white, whose subject is swan and whose predicate is white, we get the proposition, something white is a swan. Notice that the same subject and the same predicate have now been reversed, so that what was previously the subject now becomes the predicate, and what was previously the predicate now becomes the subject. Conversion rules are rules stating under what conditions the conversion of a proposition preserves its truth value. So, when we have a conversion rule, that'll tell us that a proposition which was previously true can be converted and remain true. Now let's go through the conversion rules for assertoric, apodeictic, and problematic propositions. The rules for these three kinds of propositions are not exactly the same, and therefore we have to go through them individually. We will do this with respect to a standard square of opposition, in which are found the four propositions: universal affirmative, universal negative, particular affirmative, and particular negative. As you'll recall, these four kinds of propositions are divided both by quality, that is, into affirmative and negative, and by quantity, that is, into universal and particular. Other kinds of quantity, namely singular and indefinite, are ignored in the standard square of opposition. You will also recall that each of these four kinds of propositions corresponds to a particular letter. For instance, the universal affirmative corresponds to the letter A, the universal negative corresponds to the letter E, the particular affirmative corresponds to the letter I, and the particular negative corresponds to the letter O. In this square of opposition, I've also included in parentheses a symbolism by which we can easily recognize the sort of proposition and also more easily tell what's going on in a conversion. In this symbolism, we have some arbitrary capital letter corresponding to the subject. Then we have some arbitrary capital letter corresponding to the predicate. This needs to be some distinct capital letter because the predicate and subject in each of these propositions is not the same. Between these two capital letters is a lowercase letter corresponding to the kind of proposition in question. For instance, the letter A in lowercase would correspond to universal affirmative, and the letter E would correspond to universal negative, and so on. So we have two capital letters separated from each other by a lowercase letter. The lowercase letter corresponds to the kind of proposition, and the two capital letters are chosen at random to correspond to the subject and the predicate of the proposition. Now let's look at the conversion of these four kinds of propositions, starting with the universal negative. The universal negative converts perfectly. That's because when we switch the subject and predicate, we still maintain the truth of the proposition at the same quantity. So we go from no swan is black, which is a true proposition, to the proposition nothing black is a swan. The resulting proposition is not only true like the original, but it's also universal negative, just like the original. The particular affirmative proposition also converts perfectly. We go from the true proposition, some swan is swimming, to the also true proposition, something swimming is a swan. Notice that the truth value of the proposition is preserved. Moreover, the resultant proposition is of the same kind, namely an I proposition or a particular affirmative proposition, as the original. The universal affirmative proposition does not convert as perfectly, but it does still convert. From the proposition, every swan is white, we cannot conclude to the proposition, everything white is a swan, since whereas the former is true, the latter is obviously false. Nevertheless, since every universal affirmative entails a particular affirmative, for instance, every swan is white entails some swan is white, and since the particular affirmative is able to convert perfectly, as we've just seen, we're able to conclude from the proposition, every swan is white, the proposition, something white is a swan. This proposition is true like the original, but it's not of exactly the same kind. Like the original, it's affirmative, but unlike the original, it's particular and not universal. So the universal affirmative converts, but only by means of a diminishing of its quantity. The particular negative can't convert at all. We cannot conclude from the proposition some swan is not swimming to the proposition something swimming is not a swan. The conversion rules for apodeictic propositions are exactly the same as the conversion rules for assertoric propositions. Let's again start with the universal negative. For instance, it is necessary that no swan is black. This converts at the same quantity and quality to the proposition it is necessary that nothing black is a swan. The resultant proposition is true, just like the original. The particular affirmative converts in the following way. From the proposition it is necessary that some swan is swimming, we get the converted proposition it is necessary that something swimming is a swan. Both propositions are true, and both propositions have the same quantity and quality. The universal affirmative, once again, is able to convert, but only by diminishing its quality, from an A proposition to an I proposition. For instance, it is necessary that every swan is white. Therefore, we can conclude, it is necessary that something white is a swan. The O proposition, or the particular negative, once again is incapable of being converted. We cannot conclude from the proposition, it is necessary that some swan is not swimming, the proposition that it is necessary that something swimming is not a swan. The conversion of problematic propositions is, so to speak, the most problematic. The universal affirmative and the particular affirmative still convert in the same way as the assertoric and the apodeictic propositions. For instance, the universal affirmative converts to a particular affirmative, and the particular affirmative also converts to a particular affirmative. But there is a difference when it comes to the negative propositions. That's because, as we saw earlier, there are multiple senses of the word problematic or possible. That is, the modal qualifier, it is possible that, might mean one of three things. If the modal qualifier means not impossible or chance, then the conversion is as follows. The universal negative converts perfectly, and the particular negative doesn't convert at all. So far, we're seeing the same thing as what we saw previously. Here are some examples. From the universal negative, it is possible that no man should be a horse, we get the universal negative, it is possible that no horse should be a man. Obviously, the converted proposition is just as true as the original, and they're of the same quality and quantity. But, from the particular negative proposition, it is possible that some dog should not be walking, we cannot convert without risking the truth of the resultant converted proposition to the proposition, it is possible that something walking is not a dog. So, the universal negative converts perfectly, and the particular negative doesn't convert at all. So far, it's the same as what we saw previously. But, if the phrase, it is possible that, means probable, then we don't get a conversion in the universal negative. But, in the particular negative, we now do get a conversion. So, if it is possible that means probable, then from the proposition, it is possible that some man should not be raised in the wild, we can convert to the particular negative proposition, it is possible that something raised in the wild should not be a man. The reason that the universal negative doesn't convert is more evident if we switch the word possible with the word probable. So, if we have the universal negative proposition, it is probable that no man should have one leg, we obviously can't conclude it is probable that nothing with one leg should be a man. Let's also put the word probable into the particular negative to see why that conversion now is possible. So, from the problematic particular negative proposition, it is possible that some man should not be raised in the wild, or it is probable that some man should not be raised in the wild, we get the particular negative. It is possible that something raised in the wild should not be a man, or it is probable that something raised in the wild should not be a man. In the next video, we'll discuss perfect versus imperfect syllogisms, the three figures of the syllogism, and Aristotle's strategy for proving the validity and the invalidity of syllogisms. Ite